Today we are talking about a process called U-substitution. The title is going to be a little bit longer than what's on the board because today we're focusing on indefinite integrals. Indefinite integrals. Who remembers what a couple of the differences are between an indefinite integral and a definite integral? How do they look different? Okay, that's how the answers look different. Which kind has a plus C on the end of the answer? Indefinite or definite?
Indefinite.
Indefinite. So everything we do today will have a plus C on the answer. Okay? How does the definite integral? Doesn't have DD? No.
It has the numbers on the end.
It has the numbers on the end of the integral symbol, A and the B. It has the A and the B. Okay? And when you do a definite integral, does your answer have X's in it? Or is it a number?
It's a number.
It's a number. Definite integrals come out to be numbers. Indefinite integrals come out to be equations. So we're going to be doing, both of them require the use of an antiderivative, but we're going to be focusing on indefinite integrals today. Okay? What we're going to be doing specifically is undoing the chain rule. I hope you remember the chain rule from first semester. Okay? Let me kind of give this with an analogy. Back in Algebra 1, I believe everybody in this class learned a process called foiling. Do you all remember how to foil? Math, man, if math was only that simple again, right? Okay. Then you learned a few months later a process called factoring, which some of your teachers may have referenced as unfoiling. Basically, it's taking the answer to a foiling problem and going back to the question, right? Okay. What we're going to be doing today is taking the answer to a chain rule derivative and going back to the original equation. None of the integrals we've done up to this point, well actually a couple of them have been, but the majority of the integrals that we've done to now have just been simple integrals. We're going to talk now about how to undo an integral that had been completed by doing the chain rule.
Are these
These are antiderivatives, yes. Indefinite integral is synonymous with antiderivative. You're right. Okay? So, what we're going to do is we're going to start out by practicing the chain rule forwards. So, y equals 5x minus 3 to the 6th power. That's a chain rule problem. I want to take its derivative.
It's derivative?
Its derivative, okay? I want to think about the process, and I want to look at the way the answer looks. Okay? For a minute, I'm going to go back to the old-fashioned way, writing out what the outer and what the inner functions are, because I'm going to refer back to them in a few minutes. What is the outer function for this problem? Parentheses to the 6th, right? And what is the inner function? 5x minus 3. Okay? So, if I was to take the derivative, what is the first thing I do? I take the derivative of the parentheses to the 6th, which is bring the 6 to the front. What does anything change in the parentheses?
No.
No. So it's 5x minus 3 to the 5th power. Is that it? Times the 5. Agreed? So my answer would be 30 times 5x minus 3 to the 5th power. Agreed? Okay. Now, I'm going to be dealing with a problem that looks like the answer to this derivative. Now, doesn't that look like a chain rule problem again? Yeah. Most of the chain rule integrals look like chain rule derivative problems. Okay? So once you start with a chain rule, you kind of get another chain rule problem again. And you've done some problems last semester where you had to go to a second derivative, where you do the chain rule in the first derivative, and you have to turn around and use the chain rule again in the second derivative, because it just keeps going. So, one of the skills you've got to leave with is to know when to do this. Now today it's going to be all doing the U-substitution. Later on, you're going to have to look at it and say, do I need U-substitution or not? So I'm going to turn that in as we do this. Okay? So, that's the review. Here is the first problem. There's really no notes. It's just straight practice examples. Okay? We're going to take the integral of x times x squared minus 1 to the 3rd power dx. So that is the derivative of some function. I want to know what the original equation is, what the antiderivative is. Okay? Now, I know that some of you are going to be able to do this in your head. Okay? And that's fine, but they're going to get harder to the point where you're going to have to use the U-substitution. But I want you just to watch, everybody to watch the U-substitution right off the bat. Okay? Now, let's think back to what we've done before. I told you that there is no product rule, no quotient rule, and no chain rule in antiderivatives. There's only undoing chain rule. Okay? How hard would it be to FOIL this out and multiply that x in there? Would that be worth your time? It'd be a lot of work. So this problem right here, because it's got multiple x's, is a good chain rule or U-substitution candidate. Also, that looks like a chain rule problem, doesn't it, right there? If you see something that looks like chain rule, it's going to be a good U-substitution problem. Okay? Now, here's what we do. Now, for this first problem, I'm going to recopy the exact problem because I'm going to start doctoring up the integral, and it's hard to tell what was there originally and what was not. So I'd like you to recopy this exactly as you see it, because I'm going to start playing with this integral a little bit, because this is how you actually do the work. We are going to change this entire integral from x's to u's. And in the process of doing so, we're going to simplify it tremendously so it's easy to take its integral. Okay? Here's what you want you to do. We're going to define part of this problem as u. And I'm going to come up here and write this in a bracket. U is going to be the inner function every time. So you need to look at the problem that you start with and look for an inner function. So like if you were going to do the chain rule, what would be the inner function? What would be the inner function on this one? X squared minus 1. Very good. So the step one is to define u. We're going to change that yucky inside to that power to a simple u. Okay? Now, if we're going to change this to a u, this cannot say dx anymore. It's got to say du instead. It's got to match letters. So what we're going to do is we're going to take this thing and we're going to take the derivative of both sides, and we're going to write it this way. Du dx equals, the derivative of u is du dx. What's the derivative of x squared minus 1? 2x. Agreed? Okay. Now what I'm going to do is I'm going to move this du over here, and I'm going to write it this way. Du equals 2x times dx. And I want you to put the step above it in a parentheses, because we're never going to write that. We're going to go straight to the du format. Okay? All right. So now we've got to figure out how to turn all of that into u's. Okay? Now I need you to change colors. Change colors. Swap pens, change colors, whatever you want to do. I want you to draw a new integral symbol. Okay? I want you to locate what we originally defined u to be. U is x squared minus 1. Here's the part of the problem with x squared minus 1 in it. How would I write this in terms of u? What would, not u squared. That would be u to the third. Do you all agree with me there? Is that u to the third right there? So down here, I'm going to write u to the third, because that's what that is. And I'm going to basically gently mark that out so I don't try to mess with it anymore.
Wait, I didn't get that at all.
Okay, let me say it again. U is x squared minus 1. I'm looking just at that. If u is x squared minus 1, isn't that u to the third?
Yes.
U is x squared minus 1, so I'm turning the x squared minus 1 into a u. Okay?
Oh, yeah. Sorry.
Yeah, you're not the only person who's had that happen. It just takes a minute to click. Okay.
It's okay.
Now, I need to have a du after that. Okay? But over here it says the du has to be a 2 times an x times a dx. Now, what do I have in here? I have an x and a dx, but I don't have the 2. Do you see what I'm saying? In order to turn all of this leftovers into du, it has to match this. Okay? So what I'm going to do is I need a 2, don't I? And some of these problems are going to be missing a number. Okay? In this case, I'm missing a 2. And you know how I'm going to do what I'm going to do to fix that? I'm just going to put a 2 right there. You're like, wait a minute. How can you just do that? Well, here's how I can. If I put a 2 here, I have to put a 1/2 outside to balance it out, because what is 1/2 times 2? 1. Did I change the value of this integral? No, I didn't change its value. I just changed the way it looks. Okay? So now, this 1/2 comes straight down there. It's outside, so you don't mess with it. This 2x and this dx combine to make the du. And I can write it down now. Okay, I want to stop for just a minute. Do you understand how everything that was x's has now turned into u's? Yes.
How did you put the 2 there?
I was allowed to put the 2 there as long as I balanced it out with a 1/2.
Well, no, like, how'd you know? You didn't see it?
I looked at what's over here.
You're trying to get to that.
I have to make it look like this.
Okay.
Okay? Okay? Kind of some weird math. But think about, okay, if you were, back when you learned how to do common denominators, if you had to turn 1/2 into 8s, didn't you just put a times 4 on the top and bottom of your fraction? You just threw a 4 in there. That's what I'm doing. I'm just throwing a number in that I need as long as I make it equal 1 by putting the 1/2 outside. Okay? All right. Now, isn't this problem a ton easier looking to do than this problem up here? Integrating that should be a piece of cake. Okay? So now what we're going to do is we're going to go ahead and integrate it. So bring down the 1/2. Draw your parentheses. What power does u go up to?
3.
It goes up to 4. What goes in the front? 1/4. Remember that? And what did I say every answer on this problem has to have? Plus c. Remember, integrals increase in power. So the 3 goes to 4. It doesn't go down. It goes up. Okay?
You just disappeared right there?
No. It's right there.
No, the du.
The du. Every time you take an antiderivative, as soon as that power goes up, these two markers, the integral and the du, drop off. They drop off. Okay? Now, I started in x's. I have to end in x's. So I changed this back. What's 1/2 times 1/4? 1/8. Change the u back to what it was. X squared minus 1 to the 4th plus c. And that is your answer. That is the antiderivative of that integral right there. Okay. For this very first problem, I want to check this to make sure I did it right. So, how do you check an antiderivative? Take the derivative. So I'm going to take this answer and make it an equation, y equals 1/8 x squared minus 1 to the 4th plus c. And I'm going to take its derivative. Okay. For those of you who need it, the outer function is the 1/8 and the parentheses to the 4th. The inner function is the x squared minus 1. So what am I going to do first? I'm going to bring the 4 down and multiply it to the 1/8. What does that become? 1/2. Parentheses. X squared minus 1. What is the new exponent? 3. Derivatives decrease in power. Times 2x. And what's the derivative of the c? It is 0. Okay? I want to show you something. Do you see this number and this number? Isn't that the two numbers I introduced in the integral? Yes. What's going to happen to them right now in the derivative process? They're going to cancel out. But since I'm going backwards here, I have to make them reappear so I can take the antiderivative. Okay? So these two numbers are these two numbers that I made reappear right here. Okay? So my final answer is going to be, bring the x to the front, because those cross out, times x squared minus 1 to the 3rd, and lo and behold, that's what I started with. Okay? Any questions on the process that I did? Okay, let's do another one. We're going to do that, well, because I checked it, and I talked so slowly through the process. They're going to start going faster. Okay? Bear with me. So, integral 3x minus 2 to the 4th dx. Okay. Now, I'm not going to recopy this one just because I'm almost out of room. Okay. Remember that u is defined to be the inner function. What's the inner function that you see? 3x minus 2. Okay, what is du? 3dx. You've got to write the dx on there.
So you just take the, okay.
Just take the derivative of 3x minus 2. Okay. All right, so now I'm going to write my integral symbol. I'm going to take the part that had the u in it, right here. How do I write this in terms of u? What is that? U to the fourth. Very simple. That takes care of that. Okay, all I have left is dx. But in order to change it to du, it needs a 3. So what am I going to do? I can put it here. I can put it back here. I don't care where I put it as long as it's in the integral somewhere. I'm going to put it there next to the dx because that's where it's going to be. But I have to put the 1/3 out front. And make sure you bring that 1/3 down. First period I accidentally forgot the 1/3 in the problem. That was not good. So here's 3dx. It comes over here, turns into du. Because du equals 3dx. Are you with me? Okay. The next step after it's turned into u's, now that's an easy integral. So we write the 1/3 down. The integral symbol drops off as soon as you're ready to start raising power. Some of you are not dropping your symbols off when you need to be. Okay? So, u to the what power does it become? 5, and then a 1/5 in the front. Don't forget plus c. Now we change back to x's. So it's going to be 1/15 times u. U was 3x minus 2 to the 5th plus c. And there's my answer. Questions?
When you're multiplying fractions, you multiply across, right?
Correct. Correct. Multiply tops and bottoms. I was helping my son with homework last night, and it's something, if you don't do it very often, you forget. Or if you always put it in the calculator, you forget. I know. No, he's in Algebra 2. Okay. Next problem. Integral cosine 4x dx. Okay.
Oh, we're really going to do trig.
Yes, we're really going to do trig. No, afraid not. Okay. Some of you, when you go to college, are going to be asked to take a business calculus course. Well, it is not actually not as much. You'll like it because business calculus is calculus with no trig.
Oh my gosh, thank goodness. And there's a point to it.
Well, there's a point to this too. Excuse me. We're getting there. We've done some related rate problems. We've done some other stuff.
Yeah.
So, yeah. Okay. Yeah. All right. This one, because it's trig, I'm going to recopy the first time. Okay. Okay. Yeah, basically we're learning the ABCs of calculus, and then you branch out into the different fields, engineering, medicine, whatever, and then you start learning the real how do you use it kind of stuff.
Is there trig?
Oh my gosh.
Oh yeah, oh yeah, lots of it. Okay.
Do you remember that kid that's like, where do we use this in real life?
Yeah, I'll tell you. I'll after I'm done teaching, I'll talk about that. I have a perfect answer for that now. After so many years of teaching, I've got a perfect answer for that. Anyway, okay, now. This one's not quite so obvious. What do you think the u is? It is 4x because the 4x is inside the cosine. Okay, so what is d? 4dx. Okay. Now time to switch colors. So integral. Find the part with the u, which is right here. How do I write that in terms of u? Just cosine of u. It is still cosine. Don't try to take its antiderivative yet. Okay? Can I just change this to du, or do I have to add a number? Not add a number, I'm really multiplying a number. What do I put in here? Put a 4, 1/4 out front, bring down the 1/4. So now this becomes du. All right? Okay, now we take the antiderivative. 1/4 parentheses instead of integral. What's the antiderivative of cosine? Sine or negative sine?
Sine.
It is sine of u plus c. Do not forget the c. Okay, now switch back to x's. 1/4 sine. What is u? 4x plus c, and we are done. You notice that they're going a little quicker now. Okay? All right. No, I'm not having to explain as much in between. Okay, it is your turn to try one. This is your try. Here we go. Integral. Secant squared 6x plus 1 dx. Secant squared 6x plus 1 dx.
It all makes sense when somebody tells you.
Okay, give me a minute to do this.
You called me dumb, Joe. Nobody wants you to read.
Helps if I can get some back. Okay, moving on. Next problem. I've got about 3 more to do.
Goodness gracious.
And I'm not even finishing my notes today. Okay? Yeah. Because there's so many variations on this, we have to do lots of examples. Integral. 3 sine parentheses 1 minus 3x dx. Integral 3 sine parentheses 1 minus 3x dx. Okay? What we're going to be talking about now is what if there are numbers in there that aren't exactly what we want. Okay?
That'd be all of them.
Yeah, I hear you. Okay, let me move this up. What do you think u is? 1 minus 3x. Hopefully the u is rather obvious. Okay, it's going to get to a point where it's not always obvious. Some of these the parentheses kind of give it away. What is du this time? Negative 3 dx. Okay, we'll tackle du in a minute. Switching colors. Okay. Ignore the 3 for just a minute. Focus on this right here. How do I write that in terms of u? That's just sine of u, isn't it?
Yeah.
So we write sine of u. Okay. But du is supposed to be negative dx. What I have left is positive 3 dx. Can I just put a negative on there?
No, do it negative. Then you have to put a negative 1 on the outside.
Very good. Okay. You can make that a negative because you're multiplying by negative 1. But then we're going to turn around and multiply the outside by negative 1 as well. I'm putting in parentheses because it's so crammed against the example. So when I bring it down here, I'm putting negative 1 there. This and this make du. So now we take the integral. What is the antiderivative of sine? Negative cosine or positive cosine? Negative cosine. Very good. Negative cosine, still u. I've dropped the integral symbol. What else do I need? Plus c. And now I've got to turn it back into x's. The two negatives become a positive, so it's cosine of 1 minus 3x plus c.
I have a question.
Yes?
Do you just take the antiderivative, like, okay, you know how u is what's inside the parentheses?
Yes.
And then whatever's on the outside, like with the trig function, it's like you just take the antiderivative of that at the end. You don't like change it throughout.
Correct. Whatever trig here until I take the integral symbol off.
Okay,
So it's change it to u, take the symbol off, change it back to x. Okay? You're welcome. All right. Questions on this one before I move on? Okay. 2 more. I got to go to another sheet of paper because I'm writing big. Okay? Now, changing that 3 to a negative 3 was easy. But what if you need a 3 and you have a 7? Or what if you have a 3 and you have a 1/2? Then you have to, I have another way to do that. Integral square root 3x minus 7 dx. Okay. Now, this one I am going to recopy because I don't like the way this looks. How can I rewrite this so it looks like a chain rule problem? 3x minus 7 to the 1/2 power. Exactly. Okay. Start it just like the other ones. What is u? 3x minus 7. You're ahead of me. Okay. Du is 3dx. Okay. Leave that alone for a minute. So we switch to other color. Now, focus on what u is. How do I write the u part in terms of u? U to the 1/2. Okay? Okay. I need everybody caught up with me and paying attention for just a minute. Okay? I need 3dx. I have 5dx. Now, there's 2 ways to do this. Method number 1 is having the mental acuity to be able to know what to multiply a 5 by to turn it into a 3. And some of you can do that. But my mind doesn't work that way. Okay? So I have an easier way to do this. How many of you can real quickly figure out what you multiply a 5 by to get a 3? Okay? Good. You can do it that way. Here's the other way you can do it. If your brain doesn't work like that, like mine, here's what you can do. Do you remember that numbers can move in and out of integrals at will? You remember me telling you that as one of the properties? Well, that 5 is in my way. So you know what? He's going outside. He's in my way. I'm moving him out. Okay? Now I'm going to introduce the number that I want. What number do I want? I want a 3. So I'm going to squeeze the 3 right in there. But what do I have to put outside to balance out the 3? The 1/3. So multiply by 1/3 out there. So, if a number is in your way, kick it out. Kick it out of the integral. Can you kick x's out of integrals? No, you can never kick x's out. You can only kick out numbers. So this now becomes 5/3. Here's my du, and I'm ready to go. Everybody cool with the kicking out the number and putting in what I want? Yes?
Can you do it the other way where you just really take the 3 digits and you just stick it outside of the integral?
No, what you would do is you would put the 3/5 here next to the 5 to convert it to 3, and then you put its reciprocal outside, which is the same 5/3 that I have right there. Okay? All right. So now, copy down the 5/3, parentheses, and your u. What power does u become? Integrals increase in power, so it goes up to 3/2 is the power. In the parentheses is what? 2/3. Don't forget the plus c. Changing back to x's. So this will be what over what? 10/9. U becomes 3x minus 7 to the 3/2 plus c, and I will let you stop right there. I used to say you had to turn it back into a radical, but I'm not going to make you do it. Okay? All right. Hang on, Ben. Let me give you some. One more paper. Take that with you too.
Not really. Not
Okay, one more problem and we're done. Any questions on this one? I know this is a lot for my last problem. The integral of sine cubed x cosine x dx. That's what we're going to find out. Okay.
Do we have two U's?
No, we don't. Not exactly. Okay. In the scenario where you have two trig functions, one is the u and the other one's the du. Okay, watch this. I need to rewrite this. And I'm going to pull that third power out because isn't this the same thing? You see it now? Cosine x dx. There we go.
Is that what that means? Like, is it always
Yeah.
what that means?
Yeah.
I've never understood that myself.
Okay, well now you do. Okay. Let me say what I just said one more time.
What?
In the instance when you have two trig functions, usually one is u and the other one is du. And I happen to point to them showing you which one was which if you were paying attention. Which one do you think the u is?
Cosine.
No, it's probably sine.
Which one is the inner function? Which one's inside the other one? Sine is. So u is the sine.
It says sine U.
Du is cosine of x dx. And for the first time on this entire paper, I have everything I need for du already, right off the bat. So I don't have to introduce any numbers. But I do need to change it to u's. Okay, this right here, how do I write that with u's? That's u to the third. All of that is du. Quick change.
So du
Now we got to integrate it.
is the derivative of the sine
Yes.
of u, and then times sine.
Okay, so now what's the antiderivative of u to the third? 1/4 u to the fourth plus c. Switch back to x's. 1/4 of sine of x to the fourth plus c. Or you can write it with the 4 back inside. 1/4 sine to the fourth of x plus c. Either answer is correct. Just put the 4 back inside where it came from. All right. Any questions on that problem? Okay, here we go. First example for today. We are going to do the integral of x over x squared minus 4 dx. Today we're going to be focusing on problems that have fractions in them.
Oh, joy.
How we're going to do the area, or the antiderivative. I don't know why I said area. I'm thinking of the test. How we're going to do the antiderivative of this. Okay. When you are given a problem with a fraction, I have a hint for you, and that hint is u is usually, but not always, usually the denominator. If you're dealt with a problem, especially this one where nothing is inside of anything else, because remember yesterday we talked about u is supposed to be the inner function. If nothing is inside of something else, u is usually the denominator and du tends to be the numerator. You can never have a du on the bottom of a fraction, ever. Okay? So, we're going to do this just like yesterday. U equals du equals.
Do you go through these notes with every class, or do you just show them the video from this class?
You're my last class. So, basically I'm practicing it first and second to get it right with y'all. Okay. And so that's why my videos that are cold that I do, by myself up here, sometimes I stumble over myself and go, wait a minute. Usually I worked all the bugs out by the time I get to third period, so you guys are the lucky ones there. Okay, u is the denominator, x squared minus 4. That's usually where you want to start guessing. Sometimes it is a guess, sometimes it's obvious. Okay, what is du? What's the derivative of that? 2x dx. All right, so now we're going to switch colors. We're going to draw our new integral. Okay. Now, U is the denominator. So I'm going to write a fraction bar, and I'm going to put a U on the bottom because it doesn't have a power on it or anything. Okay, now, mentally I'm just going to ignore the bottom because I'm done with that. Is everything that's left in the problem a component of du? Is it a part of du? It may not be all of it, but is it part of du? Yes, I've got an x and I've got a dx. What's it missing? It's missing a 2. So what do? Give it 1. And then what do we put outside? 1/2. Very good. So half goes there, half goes there. So now all of this right there is what? That is du. Okay? You have two choices as to where you put it. You can put it on top, or you can put it out to the side. And I think it's easier to put it out to the side. So put a 1 on top and a du out to the side. That's everything. Everything has now been accounted for. Hopefully you remember what that is, because guess what? That was on your formulas quiz today. ln, absolute value of u, plus c. Plus c. Okay. Real quickly, because I'm going to cut this out of the video. Raise your hand if you remember the absolute values. About 2/3 of you. Raise your hand if you remember the plus c. Oh, more of you. Okay, good. Okay. I told you when we went over that, from this day forward, you must put absolute values on your natural logs every time. So no. Okay, if you forgot to write natural log on your quiz, it's wrong, period. If you forgot the absolute values, it's half off. If you forgot the plus c, the other half is off. So if you forgot both, it's wrong. If you put just ln, so you forgot the absolute value and you forgot the plus c, sorry. No, that's it. That's it. Okay. So now we switch back to x's. So this will be 1/2 ln absolute value x squared minus 4 close absolute value plus c. There's your answer.
Why don't we just make it 2x parentheses x squared minus 4 to the negative 1?
Good answer. Good question. Why don't I just move that to the top? Okay. Let's talk about that for a minute.
Because then wouldn't you be able to do the anti-chain rule?
The anti-chain rule. Okay. If we did that, the power on that x squared minus 4 would become what? It was negative 1, so now it goes up to 0. And then you have to put the reciprocal in front of it. And there is no reciprocal for 0. So that's why we can't do it. So that's why this specific problem, when the power would become negative 1, has to default to natural log. Everything else you do exactly like you said, except for when the power is negative 1.
Okay, but if it was on the bottom in parentheses squared, would you be able to move it up?
Yes, yes, exactly. And that we're going to do one like that in just a minute. Good job. Okay, next problem. Example. Integral e to the x over the cube root of 1 minus e to the x dx. E to the x over the cube root of 1 minus e to the x dx. You need to cover all the bases so that when you take the worksheet home, you don't cry at home. Okay? All right. Now, yesterday I mentioned that u is all. Now, does something look like it's inside of something else in this problem? Yes, the 1 minus e to the x does. And so that is u. U is 1 minus e to the x. What is du? It is negative e to the x dx. Okay, does everybody understand why it's negative? Okay. All right. So we're going to draw our integral with the fraction bar. What are we going to write on the bottom of the fraction? Cube root of u. Cube root of u. Okay? Do I need something else for my du? I need a negative. What do I put outside to balance it out? -1. So put a -1 on both the integrals. This now is all du, which I'm going to put out to the side and a 1 on top.
Why are you putting it out to the side?
Because I'm about to show you. Just hang on. Okay, it's a lot easier to see what to do to it next when it's out to the side. Okay? So now, I'm going back on what Christina was just talking about. Could I bring this up and make it a negative power? And the answer is yes. This is not a natural log problem. Do you know why?
I have no clue.
Because natural log is just straight 1 over u to the first power. It cannot be to any other power, any other radical, any other anything. So, what I have to do in order to work this problem is write it as -1 integral of u to what power?
2/3.
No. -1. It's negative because it's on the bottom. 1 over 3 du. Okay. Who can explain why I haven't taken the integral sign off yet? Because I am just rewriting the problem. I'm not integrating it yet. Okay? So now I'm ready to integrate it. So we're going to do -1 parentheses. Write the u. What power will -1/3 become?
2/3.
Positive 2/3. It goes up. In the parentheses goes a 3/2. The du and the integral fall off because I'm done raising the power. But what do I need on the end?
Plus c.
Plus c. And now it's time to switch it back to x's. -3/2 parentheses 1 minus e to the x to the 2/3 plus c. There it is. Questions? Okay, I have one more problem to do and then we're finished. Okay? Is everybody done writing this one down? Okay, this one is the ugly one. If you want to give it a name, it's the ugly one. You're going to need about half a sheet of paper, so if you write big like I do, so yes. Okay, it is the integral of x squared over the square root of x minus 4 dx. Now, you look at it, you're like, that doesn't look bad. There's no e's and sines and cosines in it. That doesn't look too bad. Some of you are going, yeah, it does. It's got square roots in it. I don't like it. It's got x's. Oh, no. It's got x's in it. Okay. All right.
Square.
Okay, once we define u and du, hopefully you're going to see how this one is totally different than anything we've done so far. Okay? Some of you are already seeing it. Okay, what do you think u is? Just x minus 4, not the square root, just what's inside. X minus 4. What is du? 1 dx. So just drop the 1 and write dx. Okay? Okay. Now, real quickly, raise your hand if you see that there's going to be a problem. How many of you see a problem arising already? About a third of you. Okay, let me show it to the rest of you. Okay? All right, forget the top. Forget the dx for a minute. Shh. In the fraction, what goes on the bottom? Square root of u. Okay? Du is dx. So we just write du for the dx. But now, here's the problem. I have x's with nowhere to go. Everything must change to a u. But that x did not become a part of the dx. So it's still there. So I need to change it to u's. Okay? Now I want you to look at what's up there. There is something up there that's going to allow us to change that x squared into something in terms of u. Does anybody happen to see what it is? He knows.
Isn't it like it's x going half on the bottom and then it's x squared?
No, because that's x squared and that's u. They have to all be u's. Does anybody see it?
It's the integral.
No, it's not the integral.
Something with the x squared.
Math jokes, clever.
Okay, let me ask you this. Forget about the fact that x is squared. Do you see a way that you can turn an x into a u?
Oh, x equals u plus 4.
Say that again.
X equals u plus
How'd you get that?
like,
You got it from right here, didn't you?
like you move over the...
You moved the 4 over. Isn't u equal to x minus 4? So that means that x is equal to u plus 4. Do you agree with that? I just rearranged the equation.
Yeah, that's it.
Okay? So if u equals x minus 4, x equals u plus 4, and x squared would be u plus 4 squared. There we go.
Wow.
Okay. That is gross. It's not, usually when we change to u's, it's pretty. It's such a pretty easy problem. That's almost as bad as the original, isn't it? But it's really not, because why is this better? Because the bottom is a single term, a single u. And this is something that we can manipulate and then actually integrate. We can't integrate this the way it looks. It's impossible. Okay, now, the first thing I'm going to do is I've got to clean this up. I can't integrate a quotient. It's impossible. And I can't integrate something with u plus 4 that's squared. So what I'm going to do is I need to do something to this that I've done in the past. How do you take it when you have a single term on the bottom and you need to integrate it? Does anybody remember how we've done that? Say again, Isabella. You split it up. We're going to split it into separate fractions. But I can't until I FOIL this out. So I need to FOIL this out first. So this will be what? What's first? U squared plus 8u plus 16 over, I'm going to rewrite this as a power. What power is that u really? Okay, it's still in the bottom. I'm not moving it up. It's still 1/2 du. Okay, still got the integral. I'm just rewriting it. Okay, now I need to take this and I need to break it. I'm not going to write it as separate fractions. I'm just going to use my finger and cover stuff up. When you have u's like this, what do you do to the exponents? Subtract them. What's 2 minus 1/2? 1.5, make it improper. 3/2. So the first one will be u to the 3/2 plus. Look at this. 8u to the positive 1 on top minus 1/2, positive 1/2. 8u to the 1/2. Last one.
I'm not following where we're going with this.
Are you not following the math that I'm doing, or why I'm doing it?
Where are you getting this from? Like, what do you?
I am putting each of these over the denominator individually.
Oh, okay, I remember this.
Okay. Now, what about that last one? 16 and the u on the bottom. You need to bring it up. So we're going to have 16u to the negative 1/2 du. Now that's something I can integrate. And you're like, ugh, I've already done so much work. Yes, I know. Okay, equals. Integral sign now drops off because powers are starting to go up. Parentheses, write the u afterwards. What power does u become? 5/2 goes up. What goes in the parentheses? 2/5 plus. Copy the 8, parentheses, write the u. This one goes up to 3/2. What goes in the parentheses? 2/3 plus. Copy the 16, parentheses, copy the u. Positive 1/2. 2 goes in there. Don't forget the plus c. Are we done? Nope. What do I have to do? Change it back to x's. Last step. 2/5, parentheses, x minus 4, 5/2, plus 8 times 2/3 is 16/3, x minus 4, 3/2, plus 32, parentheses, x minus 4, 1/2, plus c.
We better not ever have to do one of these problems for real, because this sucks.
I'm sorry. And you have just said that now for posterity's sake. Thank you very much.
It's hard. That was a lot of work.
That was a lot of work. Okay. But here's what I want to do for a minute before we say the end. Okay. Who can explain to everybody else how you know when it's going to turn into one of these ugly ones? How do you know?
When there's not just an X.
Okay. Alex said when there's a squared on top. That's not necessarily the case.
When there's a square outside.
Okay. Okay, there's a lot of different correct answers. I'm going to focus on what you said. You said when the power on the top is bigger than the bottom. That tends to be the case, yes. If the power on top is bigger. Okay?
Like a rule or like...
Pretty much it's going to happen when the power on top is bigger than the bottom. So you kind of have a heads up that it's going on. There's another one. Somebody else said something else. What'd you say? Outside of the radical. It doesn't necessarily have to be a power. But listen to what I'm saying. What happened was, when did we notice it? We noticed it once we put the U in here, once we put the DU in, we had leftovers. The key is leftovers. If you have leftover X's with nowhere to go, then it's going to be ugly. Okay? That's the key.